If you're running a manufacturing operation in Indiana, the way you get energy could look very different from the last 20 years. Rivian is about to run its Illinois factory with 10 megawatt hours of dispatchable storage built from Second Life EV batteries. At the same time, Steel Dynamics has turned on a $300 million biocarbon facility in Mississippi that will help fuel its steel mill in Butler, Indiana with something other than coal and coke. In the next few minutes, I'll walk you through what those two projects actually mean for your peak demand costs, potentially, your fuel exposure, and the questions to put in front of your team if you want to stay ahead of where industrial energy could be going. If you use a lot of power at a single site in Indiana, what Rivian is doing in Normal, Illinois is a real blueprint for taking some control back from your demand charges. Rivian and Redwood Materials just announced a partnership to deploy an energy storage system at Rivian's manufacturing plant in Normal. Redwood will take more than 100 Second Life Rivian battery packs and integrate them into a Redwood energy system managed by their pack manager technology. Together, that will deliver about 10 megawatt hours of dispatchable energy on site. Now, the stated purpose is clear: reduce energy costs at the factory and relieve pressure on the grid during peak periods. EV batteries are often one of the longest lasting components of a vehicle, and they can remain usable long after the vehicle would be retired, which makes them very good candidates for stationary storage where weight and size are less critical. Redwood's whole business is designing large scale storage systems for new and repurposed batteries and recycling them at end of life to recover materials like lithium, nickel, cobalt, and copper. For you as an Indiana manufacturer, this is not about copying Rivian's exact setup. It is about understanding the pattern. First, they're turning their own used packs into an asset that can shave their peak demand, support grid connection, and potentially create a cheaper virtual plant inside of the fence line. Second, they're partnering with a specialist rather than trying to become a storage integrator themselves. And third, they're doing it at industrial scale. It's not just a science project. If you sit in a territory with high demand charges or limited capacity on feeders, Second Life Storage is one of the tools that can let you run more load without paying as much for your highest 15-minute interval of the month. It can also give you a buffer against short grid disturbances that would otherwise trip your sensitive processes. Seems like a good bet. So, what should you watch? Watch for hard numbers from Rivian and Redwood on cost savings, payback period, and how often the system actually runs during peak events. Those numbers will let you know whether similar projects are ready for prime time in Indiana or they're still at early stage. And one question for your team is this: how could we evaluate Second Life battery storage for Indiana facilities, including technical fit, interconnection, safety, and whether the economics pencil out for our specific load profile and rate? Now, on the other hand, if your operation buys steel from Steel Dynamics, competes with them, or watches heavy industry as a leading indicator, this new biocarbon facility changes part of the cost and fuel picture for one of Indiana's anchor steel mills. Steel Dynamics has opened a $300 million biocarbon facility in Lowndes County, Mississippi, as a joint venture with Michigan-based Aymium. The site sits on roughly 90 acres and is designed to chemically break down organic waste, sawdust, and thinnings from forests and timber mills into about 200,000 tons of biocarbon products each year. SDI's CEO, Mark Millett, told local leaders that this biocarbon will replace coal and coke in their steelmaking operations. He called it a way to lead decarbonization in the industry and said the technology to do this is already here. It's not something that might show up later. The fuel from this facility will go to SDI's mill in Columbus, Mississippi, and to the Butler, Indiana mill. The project will also create nearly 100 jobs by the end of 2026, with average salaries between $110,000 and $120,000. That's a good deal. Here's why this matters for you in Indiana. First, if you rely on SDI's Butler Mill, part of the furnace fuel supply is being diversified away from fossil carbon. That can help with long-term supply stability if coal and coke supply chains tighten or face more regulatory friction. Second, as customers start to ask more questions about embedded emissions in steel, SDI will be able to point to biocarbon in their process that came from a competitive angle when you bid on work that includes lower carbon materials as a requirement. Third, this kind of investment usually does not happen in isolation. SDI and Aymium are betting that biocarbon can support large-scale electric arc furnace operations. If it works well, you should expect that model to spread. You do not need to copy SDI and build a biocarbon plant, but you should be asking, where in your own process do you still depend on single source fossil inputs that could be swapped out for more flexible or more secure alternatives? And what would that do to your exposure over a 10-year horizon? So, what should you watch? Watch how SDI reports on biocarbon use at Butler. Any mention of cost impact, furnace performance, or changes to product positioning. Also, watch for future supply contracts or long term offtake agreements that tie mills and biocarbon producers together. Those can hint at how fast this becomes the new normal. And here's a question for your team. Are there places in our production line where an alternative fuel or feedstock, similar in spirit to SDI's biocarbon, could give us better long term cost stability or help us meet customer requirements without relying on one fragile input? Now, today you've heard two different but related plays. Rivian turning used EV batteries into 10 megawatt hours of on site storage at an Illinois plant, and Steel Dynamics using organic waste in Mississippi to fuel a steel mill in Butler, Indiana. One is about how you handle electrical demand at your facility, and the other is about how you handle physical fuel in energy intensive processes. Together, they show this: large industrial players are not waiting for utilities or regulators to hand them perfect conditions. They're building their own levers: storage inside the fence line, new fuel supply chains to keep costs controllable, and operations resilient. For Indiana manufacturers, this is both a warning and an invitation. If you sit still with the same load profile and the same fuels while your suppliers and competitors start changing theirs, your cost structure and your positioning may well fall behind. The bottom line today is this: you should be deliberately evaluating where storage and alternative fuels belong in your operation, not as buzzwords, but as tools to flatten demand, diversify inputs, and make sure your cost of energy and materials is not completely dictated by someone else's decisions. You're all too familiar with that. Now, obviously, I don't run your plant. You do that. My real job as CEO of Tactical Energy Group is to stay on top of everything that changes the cost and reliability of your power and the economics of making things in Indiana. And that's so that we can build the right products and programs for the manufacturing community. But while I'm doing that work anyway, this brief is my way of giving you as much of that insight as I possibly can, so you can spend more time running your operation and less time trying to decode your bills, decode rate cases, and understand the headlines. So let me give you a few questions you can take straight into your morning huddle. If you can't answer these specifically, it means your energy and fuel strategy probably lives more in hope than in a real plan. Here are some questions for the morning huddle. Given the growing availability of second life EV batteries, what are the specific energy storage technologies and financial incentives we should explore to reduce our peak demand charges or improve energy independence at our Indiana facilities? Energy independence, that is a good phrase. If we sketched out our load profile across a typical month, where would on site storage actually change our highest demand intervals? And what would that do to our all in cost under our current tariff? How can we proactively identify and integrate sustainable material inputs or alternative fuels into our production process, similar to Steel Dynamics' Biocarbon initiative, to enhance both environmental performance and supply chain security? And number four, for our top three energy intensive steps, what is our plan if current fuels or feedstocks become more expensive, harder to source, or politically constrained over the next decade? Now, if this brief helped you see Rivian's storage project and Steel Dynamics biocarbon facility as levers you could adapt instead of headlines to scroll past, send it to another Indiana manufacturing leader who should be thinking about storage and fuels before they're forced to. These are the kinds of shifts that reward the people who prepare early and penalize the ones who only react after the fact. Now, if you want more tools and context like this, you can always find us at tacticalenergygroup.com. I'm Daniel Burke. This is TEG Daily, Indiana Manufacturing News, and I will see you next time.